So today, osmia, and then if we get through that, we'll bleed into Heriades, I think. We're continuing genera in Megachilidae. So these both have, these both are not parasitic, have no parasitic members that I'm aware of. And the females would have scopal hairs underneath their abdomens. And we will get into differentiating them. They come from two different subfamilies. I can't recall the names for those subfamilies, but they're probably up on the Discover Life site. And it has to do with the propodial pits is the way that I split those out. Let's jump to the memorization chart here, and we'll deal with female osmias first. We go over here. So actually, osmias have one character that no one else has that I'm aware of. There's several other ones that lead you and point towards that character, but they have the parapsidyl lines, which we're going to see here in a second, which are the lines just to the inside of where the tegula are on the scutum. Those are incredibly short. So we're going to see a very long one, the longest that I know of, which is still very short, shorter than any of the other genera groups, and an extremely short one, which is almost difficult to find sometimes, whether that's there or not. So if you see that, you know it's an osmia. Osmia, as we'll see in a second, are mostly blue, sometimes a very dark blue, sometimes black. Most of those black members are either very far up north or in the west. In the east, pretty much everything south of New England is going to be blue, but sometimes those blues can be quite dark. The introduced osmia taurus and cornifrons are good examples of something that looks almost black in the males, and the females to some extent too. Okay, so if we're looking here at the female osmia, so it has, like many of the other of the members of Megachilidae, has two submarginal cells. It has no pale markings on the integument. So different groups of genera within Megachilidae have pale markings. At the extreme end, you have the Anthidiine ones, lots of yellows and cream colors, and sometimes even dark reds. In this case, it's always a dark integument, so no pale markings whatsoever. It has a aurolium, so there's one way to separate it out from what we saw last week was Megachilidae has no aurolium, and it isn't all dark B2, but it also has a long parapsidyl line. Am I in the right one here? I think I may not be. Let me just scroll back over here.
We also have in the chat that we're going to add dark green to the possible colors.
So dark green. So a lot of the males in particular can shade towards a metallic green coloration too. So blue, and which is the case for most of the females, and then a lot of the males. Not a lot, but some of the males, like Osmia pumila, one of the most common, perhaps the most common native eastern bee, has shades of green. And then when you get out west, which we don't see this species, except in one odd rare case in Virginia, there are bright, shiny race car green osmia that are like the same coloration as you might see in Agapostum and Algochlorella. Those groups, and both the males and the females can be bright, shiny green, and often particularly the males can be difficult. I know from talking with people at the Logan lab to tell apart, and they're still working on species level IDs. We will circle back, and when we get down to species stuff, we'll try to bring in Terry Griswold to talk about osmia and all the details of telling the species apart, which are many. So here I am in the right cell to talk about to talk about the genus level characters for the female for Osmia, 2 submarginal cells, no pale markings on the integument. There is an aurolium. Parapsidoline, which we'll see in a second, is condensed to a simple, slightly large pit, or as you'll see in this Osmia texana that we're going to show, a extremely short line. And now I've lost track of where that went, but those are the basic ones in terms of, it's basically the parapsidoline that will confirm that it's Osmia. And you have race car green to blue in most cases for the females, some members with a distinct greenish tinge to the blue. Usually it's a blue-green kind of thing in the males. To slightly brown, that would be the introduced Taurus and Cornifrons group, to dark black. But they all have this very shortened line. Now, we will go and see that. So here's Osmia texana, which is a very big species, and it is a specialist. There are a number of specialists in this group. Where's my magic piece of vellum paper? Here it is. There are a number of specialists in this group. This one's a specialist on thistles, and it seems to tolerate introduced thistles too. So here's the scutum. Here you can maybe make out, and I'm going to show this better, but I just want you to orient. There is a relatively long, this is the longest I know of in any Osmia, parapsidoline. So a normal bee of any kind, so there's a central line, and then these parapsidolines are quite extensive. These are super short, and you'll see in the next species how, so I'm going to keep that crosshairs there for orientation. It's in the upper left quadrant, and I'm going to change the light here a little bit so you can maybe make out a little bit better that parapsidoline in that quadrant. So it's going to look like a different surface texturing sometimes. Sometimes it's slightly raised, sometimes it's slightly narrowed. But if you look closely, it's not the normal pitting. So let's zoom in now on that and see if we can see that. We should a slightly bit better. Thanks again to Craig for lending us a scope so that we can see these things. All right, so here we are. You can see it mostly is a different kind of conformity in the general pit background, this landscape of pits. And here is this very long, for Osmia, set of raised areas, and this a slight trough connect together, but it's really more this raised line. And it's more of a shiny raised area. And when we see the next species, it's going to be just a very small region about the size of one of the pits. Again, here's a larger one, and it's nothing much. So you can always see it, but it's going to look like a small scar almost, but it'll be parallel, right? So, or it'll be mirrored on the other side, which you're not going to bother to see. But it's right across from the tegula, and normally it would be stretching from here to here, something along those lines in most species. Okay, dialing back out. So within the group, there's lots of nice characters. The color of the hairs throughout the body, underneath the scopal hairs, the mandibles. So here, for example, are the mandibles of the Osmia texana. And these are quite inflated. You can see that along this rim here. These are the mandibles themselves have growths on them. Just change the lighting a little bit back and forth so you can see some of that there. And then the rim of the clypeus is often used in identification too. So whether it's concave, convex, or as in the case of this Osmia texana, it has, so this is the rim of the clypeus here. It has a projecting set of two central points with a cleft in between. The classic deep cleft clypeus is found on in Osmia lignaria, which has a rectangular cut. When we get into species level things, we'll take a look at that a little bit better. I'm just trying to line this up so you can see the projecting point. It's a little bit confusing because of the scope here, but I'm going to change it so that it's more upside down. See if we can see it better that way. So quite a bit of differentiation in Osmia occurs by looking at, this is a little bit better. So here, and the mandibles tend to be massive to large in Osmias. They're hole nesters, they're manipulating a lot of things. Some carry clay, some chew up materials, some do a little modification of the area that they're living in. So here's the clypeus rim. Here is a double bump point or projecting portion of that rim, and lots of different styles of how that looks in different species. We'll do a quick, I think I can see the hypostomal cavity. This is something that people get confused by, and now that it's a species level thing, but it's something that is difficult to explain to people unless they see it. So the hypostoma, if I'm pronouncing that correctly, is the cavity in which the tongue is folded into at rest. So it's actually a slot, I would call it. Now, the trick here is going to be seeing this without having other pieces of the osmia blocking it. Okay, so let's take a look here. Here we can at least see the cleft. So here's the tongue. It's folded in, at least part of it is folded in. Labrum here. And then here's the edge, and here's the edge of the hypostomal cavity. So along this is a ridge. You can see this ridge or carina right here. And so that's what you're going to be looking for. And it is also another, while difficult to see in terms of the, you have to turn it over and find that spot and find your right angle. A lot of times you're going to be looking laterally because the shape of this ridge as it traverses, you can't really see here. I wonder if I can change some lighting on this a little bit to reflect into the cavity. Oops. Maybe not. Trying to get some light in there because that ridge continues along the side. Here, it's so dark. I'll try turning it in a second, but it's running along here, and what happens is as it travels, in some species it's uniform. So the height of the carina stays uniform the whole entire way. In others, it rises up and then comes down. Some will remain high and then abruptly drop. There's different ways that carina shape presents in different species, but it's pretty uniform. So that's often a useful characteristic. Of course, closely related species all tend to have about the same kind of carina shape, but it's always worth taking a look at. Let's see if I can illuminate that a little bit more by turning this slowly there. See if I can get some light in. A little bit. Yeah. So it may be a little bit hard, but we can play with the lighting here. So tongue, labrum, we rotated this, there's the edge. We're looking a little more laterally. Here's the carina running along the side of the hypostomal cavity. So in here is a cavity, and here it is rising up and coming down, and then it's going to curve around there. Now let me play with some lighting reflections here a little bit and see if you can see that a little bit better. Maybe I'll change the lights directly. So watch right here. Okay, so that's the highest point of the hypostomal cavity. And as I am playing with the light, you might see that it's higher at one point, and then it fades down to this area, which is curving around. That's the bend in the curve of the carina itself. So anyway, this is a good illustration of a species that has that that shape to it. So it took me a while to figure out what the heck they were talking about, but that's the heck right there. Okay, so if we leave now, there's all kinds of other species level identification characters to look at when we get to the species level. If there's questions, we can address them towards the end here and come back to that species. But I'm going to now go to a smaller species, which tends to be the most common type. You get small Osmia in the spring. Everything is spring oriented. Osmia texana is perhaps one of the last ones out because it's a thistle specialist who has to wait for some thistle to be blooming. But most things are out first thing in the spring in the east and the west and the north. So we're looking at something a lot smaller, and this is Osmia atraventris, and the pin is, I want to change this a little bit so the pin isn't so overwhelming. We also have a lot of light there, so I'm going to back that off a bit. So now we're going to look for initially, and this is a male. So we'll talk about some male characters in a second, but
Sam, what species was this?
Osmia atraventris.
Thank you.
In the female, it has a very black scopal hairs. It's very common in the spring in the east, perhaps in the west too, I don't know. Okay, so let's zoom in and see if we can find this very small parapsidoline remnant. That right there might just be it, but let's zoom in even more, and we're at the limits of it. It's not going to be much. It's basically going to be some sort of modified integument about the size of a pit. Let's play around with some lighting here. I did look at this specimen beforehand, and it was there for real. Let me change the orientation a little bit to be more forward and see what we can do now. Oops. So I am leaning towards that area right there being the remnant of the parapsidal line. Again, in this group of this subgenus, it's always really small. Let me change it is in that area, but you can see I'm struggling to give you an exactness of, because we have a lot of reflection too, but let's turn this a 180 and see if it shows up better. Hmm. Oops. We have what looks like some detritus about in the area. It should be on that side. Maybe it was the other side that I saw it. I guess what you really can see is that there is no obvious parapsital line, yet it exists. Again, it should be right in that area. We may have to stop this to see, because I'm at the almost at the limits of this, pretty much at the limits of this scope. So again, my guess is that's it right there. If I'm going to shift so my crosshairs is pointing at where I believe it to be, and you can see there's not much to go on there, but it's slightly this area right here slightly deformed and raised. It's going to be easier to see under your scope, but you can see that the area has minute to no apparent parapsital line. I guess we don't really need to see that. It's hard to see because you're seeing that right now. The other one was at the extreme level. So if you find that state, particularly if it's got a metallic nature to it, you know it is an osmia. I should point out that in the West, there are hoplites, which are very closely related and sometimes look similar-ish to osmia, and they can also have the same color range, including bright shiny green. They tend to be a little bit more elongated, and they have a very obvious parapsital line. Okay, so now we're looking in the male, we're looking at the underside, and this just bears a tiny bit of scrutiny because it's another kind of confusing place. It's rich in identification details. In fact, it's probably the place that you would spend your most time trying to discern species level identifications. It's quite more complicated in sizes and shapes than you have in like Halictidae or things like that, in the eastern United States at least. So what you're looking at here's S1, so sternite 1, sternite 2. In this species, the hair pattern, which is relatively short and abrupt along the rim, is an aid to identification of atraventris in the female. In the male. The female has all black scopal hairs, but you would not know that by looking at the male because there are no black hairs present in the sternites.
Sam, we have a quick question.
Yeah.
People are wondering how much magnification you're using, oculars and combo.
Okay, so I'm at 35x, so 3.5 on the objective, and oculars are, I believe, 10x here. I believe
I think you use 10x. That's what you told me.
Okay.
And how much does your microscope actually go up to at max?
At max, it's going to go up to 45 power.
Thank you.
Mm-hmm. Okay, so and underneath here is usually underneath S2 is S3. Usually it's mostly retracted. It's a great segment full of interesting hairs that are piled up in the middle and things, but sadly, under normal circumstances, it's retracted under here, and you can just sometimes see the edges. Every once in a while, you luck out and it's pulled out, or it's somehow open because of the way the abdomen is lying. But you'll see, for example, in Mitchell, a lot of characters that have to do with the shape of S3. So some people are pulling the abdomens apart to see those kinds of things. We tend to in the Discover Life guides not use that as much because it's so often retracted, like you see here. S4, this is S4 right in there. Let's see if I can get a better shot of that. I'm going to lean this back some. S4 is, at least the end, is usually visible, and that tends to be also full of interesting hair patterns, at least. And because it's usually visible, we tend to use it more than I'm going to think I turn it sideways here, perhaps. Okay, this is pretty good. All right, so we'll orient again, and then we'll play with the lighting. So S1 here at the base, S2, that's the rim of S2. Here's the hairs, the short hairs for this species. It's a good character, particularly differentiating from Pumalo, which is also super abundant. This is the corner here and here of S3. The rest of S3 is dipping down like this and then back up. And again, great characters, rarely seen. And then the next visible, this again, it's always, this is S4 right here. And so normally what you see is S1, S2, S4, not S3. So S3 is usually retracted, but that gets confusing because you would think that's S3, but it's not. And so it's not super visible. I'll try spinning this. This area here on S4, this part right here often has, I think always has a small CT on it. And but that the patterns of CT vary quite a bit. Sometimes they're dark, not in this case, and sometimes they're long, sometimes they're like Velcro, sometimes there's a shallow groove through there. Let's see if I can spin that. But I do want to point out one thing, which is S4 is about it in terms of visibility of these segments. There are, I think, goes up to S8 under there, but these are all retracted up in this sort of messy area up here. Sometimes the genitals will stick out, but most of the time the genitalia is also retracted and not available unless you pull it, and that's useful. But again, most people who are doing large-scale surveys don't have time to pull all the genitalia.
Sam, before you move on, can you sharpen that a little bit so I can take a screenshot of that little, that little peak of S3.
Okay.
So, yeah, so there we go.
There's your S3 there.
Yep. And now, yep, there we go. Give me a second.
Right. Okay. All right. So I'm going to spin it. And what I'm going to try and do is illuminate these hairs right here, which are the very useful hairs of the underside of these things. Let's see. Let me downgrade the magnification. And it's a little bit visible. I'll try and play with the, so here's S1 is up here. This is S2. This is the rim of S2. Underneath, but not visible, S3 retracted. S4 is here. These hairs are showing as they should, as being relatively white. And oops, I should get rid of, oh, I hit the specimen too. this is this rim here is the rim of the tergites. So there's a little notch or knot up there that sometimes helps discriminate a bunch of groups. This is the S4 hairs. I don't think I need to show anymore. They are, it's just showing you the area and that those will vary by species. I'm going to briefly show you one of the other areas. I think I'm going to pull a different specimen for that. On the propodium, the propodial pits. And
Before you go too far, we have a question.
okay.
Could you show us what and where should we look for the Discover Life character on S4? Quote, lateral edges with two distinct, though only slightly separated rims, merging into a single rim toward the center.
Yeah, that's all right. I'll do that one too. I need that. This species that we're looking at has a single rim, so that atraventris. But I will pull a oh, I don't know, an Osmia georgica, which has the infamous double rim. And so what I want to do right at the moment is show you the propodial characters, which this one should show well since its abdomen is snapped off. Okay, so what we're looking at here is the abdomen's gone. There are the legs. Here is the scutum, tegula, propodium, which is very vertical. So there's really not a propodial dorsal part of the propodial area here. It's going scutellum, metanotum, and then propodium just going right down. Normally, the abdomen is attached there, and if the abdomen is folded up, this area is hard to see. But a lot of times when specimens are pinned, the abdomen droops, which is good in this case, and exposes this propodial pit area, which I know of no other genus in which the propodial pit is useful like this. So we'll play with the lighting here a little bit, but what you're looking at is just above the attachment. That's why it's sometimes difficult to see, because you really has to be, the abdomen has to be folded away from the thorax to see in here, is an area that is hollowed out in some way or another. Sometimes it is like this, let's call it egg-like in shape, or rounded in shape. I'm going to play with the lighting directly, I think.
Sam, I was
yeah.
taking a note. What species are we on?
We're still in Osmia atraventris.
Okay, just with a popped off butt. Got it.
Yeah. I'm going to try a different angle on this. Okay, now we're looking directly at the propodium. And this area right here, it's like an egg, rounded and very shiny on the interior. It's dark in there, so it's a little bit difficult to see. This usually under the microscope, this area is pretty clearly defined. Topographically wise, it is a depression, a pit, however you want to call it, and it displays well when you're rotating the specimen in your fingers. Let me see here if anything with the vellum paper is helpful. You can see, though, a lot of reflection. Like you can see the piece of paper in the propodial pit area right here is very shiny. And I'm not sure that my amateurish efforts to decrease the change the lighting are going to show much because it's so reflective in there. It just shows up as dark. Anyway, this area, important. That's where it is, just above the attachment. Sometimes it's a slot, sometimes it's just completely dulled. And and then there's two often, again, really hard to see anything here, two side cavities to the central pit that add to it. In Atraventris, just to note what the species is presenting, very shiny, very large expanse of unmarked up integument. All right, so the double S4 rim nightmare. So we'll change that. Let me get Osmia Georgica.
While you're looking for a specimen, we also request to show the center longitudinal depression on the abdomen.
The T1 depression, whether that's shiny or not, is that that's what I'm hearing?
Mary, you can unmute if you want to clarify.
This is Dina. No, I was the one that had that question. Now I meant on, I think it's S4.
Yeah.
Maybe you could show that.
Oh, the double rim?
No, the depression.
Oh, the trough.
Yeah, trough.
Osmia conjuncta, or a Collinciae. I'll try and pull a specimen of that too. Although I recently gave away most of those, but let's see if I still have some. Okay, this is Osmia georgica, and I'm not showing the S4 character, which is useful, but I am showing the propodial pit because it's quite a contrast. So abdomen is gone. There's the abdomen attachment. The propodial pit is just a slot in this particular species, and might not really present here, but it's very dull. So there's many microscopic lines. This is when people talk about a surface being dulled. Usually you have these at very high magnification. You can see there's small inscribed lines described all kinds of different ways, tessellations. Sometimes the patterns have meaning in lazy glossum, but they're etched into lizard-like sometimes to decrease the amount of reflectance from mirror-like to, dulled. So dull is a shortcut for talking about crisscrossed by tiny, tiny microscopic lines. Here, nice slot that should, this is a small species, and in the male is tricky to tell apart, but it is a good indicator of Georgica. I'm going to get a different specimen that has hopefully the S4 character. Oop, it's over here. Visible. So the tricky thing about S4 is getting the angle of the light just right to see the rim of S4 and to see this very obscure, where the heck is it? Oh, there it is. Split end to the rim. Once you see it, it turns out to be a useful characteristic, but seeing it sometimes is hard. The way I like to talk about it is to imagine a Ziploc bag. So imagine a Ziploc bag that has been unzipped but is not opened out. So you have those two little edges to the Ziploc there. That's what it looks like, sort of. Okay, so here we have the underside of an abdomen. We have S1 is there. This is probably S2. S3 is retracted, although this bright area, we're looking down and in. This would be S3 here. These are the white hairs that you'll see. Like Discover Life often has those illustrated because Mitchell dissected them out and presents them. but there they are there. Rarely can you see them enough to be useful. And here is S4. This is the rim to the tergites. There's some genitalia probably peeking out. All right, let's go in and see if we can see a double rim. So what we're looking for is this Ziploc-like area along, should be along this rim. Oh my gosh, it's so dark there. Let's see if we can do anything about getting that lighter. It's just a pretty tricky area to see into. So this is the area. So there's S3, and this is the rim. Ugh, you can kind of see something there, but boy, that is not what you'd want to see for an illustration. And I'm at my absolute maximum. Let's see what I can see under the microscope here. See if I can see something better. Okay. I can see it in the microscope. The problem is in the, so here's the hairs on S4, and that those are used in identification. This is the rim right there, which has the double rim. Let me play a little bit with the lighting. In the microscope, it looks great, but here we don't have that greatness.
If it looks great in the microscope, I can also come back next week and maybe try to grab a picture through our adapter.
Okay.
Play with that. Put the
I
specimen aside.
can't squeeze any more magnification out of this. Right here, I'm playing around with some light changes. Let's see if I go higher up. Yeah. Well, that it's right in there, and we just don't have the resolution to see that. Well, there's a little bit more light. Manipulating the scope directly. Yeah. I'm not sure I can get any better than that. These are small. They're the same size as Pumala and Atraventris, but that's where you're looking. You're also getting the idea. Pretty darn subtle. You have to catch the angle right and wiggle it back and forth, and it's and that's the spot. It's also going to present as slightly thicker than the other species, which have no double rim along those lines. So they just come to a thin shelf, like the rims of S2 might. Let's see if we can find S2 in there too. So, which are sharp. You can see that here is S2. But again, I think we are at the limits of lighting and scope to be able to see that sort of, oh, there's S4 again. So you can kind of a little bit see the double rim there. See, there's like two, I don't know if you can or not, but that's the other edge of S4 up there. So they're a little bit better, two rims. So anyway, we're at least showing you the areas you should be looking at. Let's see if I can find a specimen of a male of Calinciae and see the trough in S4, which is a distinctive character of that species and a few others, but mostly it's helpful in Calinciae, which is tricky in the male.
We got somebody saying that yes, that helps. So yay!
Okay.
Also, a time check. We're at 10 minutes. You know,
Okay.
with our vague ending point.
Recently I gave away almost all of my Clinciae, and I have not added in any new ones, so I can't show that. I have some in the specimens to come. So maybe we'll have to punt on that one. But I will now just show a couple things before the end of Heriades. There's only a few species. I forget how many out west, but also I don't think that many more. And they're small. They're little hole nesters. They are all black. They have no, I'm getting the specimen ready here and talking at the same time, which is not great for me. They have no pale markings. The big feature for them, for a megachilidae, in other words, a species that is carrying its pollen underneath its abdomen in the female, but pretty much in the male too, because all black with a rim around the first tergite is very distinct in terms of species ID. I can think of nothing else that has that. And we'll show a couple characters here, but right now, small size. We are going to play with the lighting here. What I want you to see is this very sharp demarcation of the face, the anterior face, if you will, that's facing the propodium. They fit together. You know, that's sort of what's going on there. And the dorsal surface here that's full of pits. This is shiny in here. And there's a raised line at that where that transitions. In other species, it's a smooth line. And that smooth line is you know, feathered, so you don't have this abrupt area, and you also don't have the sharp line. I'm going to change the position here a little bit and see if we get a better look at this. So now we're facing the abdomen. Here is this sharp transition between the two with a raised line. We'll run the magnification all the way up. This is very small b. I like to nest in post hole type beetle holes. And so there's that rim. So if you see that and you see this small black bee, it is a Heriades. Although, yeah, I don't think, I'm just thinking now, do I have to worry about Ashmediella or anything out west? I don't think so.
Can you move the
someone
crosshair
can
so I
correct
can
me.
grab a screenshot?
Oh, yeah. Okay, where are we? There we go. Okay, let me get that out of the way. Is that good?
Got it.
Very heavily pitted too. These are deep pits compared to the small size. And we're going to now shift, and you'll see right here. So here's the scutellum, change the focus. And that's the scutellum where my marker is. Metanotum is sort of hidden there. And I don't think that's the metanotum. I think that's the top part of the propodium. There's a set of squarish pits that run along this whole side. I believe Ashmediella has the same thing. They're in the same group, maybe Cholostoma too. We'll come back to those groups, but let me just show that to you in a slightly different angle in a better way. So you see those. So Osmia would not have this, Megachile would not have this. So when you see in this particular species, these squarish, Stelis does have that. I think it's in the same group, Stelis. This is a parasitic bee, so of course in the female it would not have scopal hairs. So we'll zoom in, but here you can nicely see there's the carina on the abdomen, T1. These are the set of squared pits. That line, I want to say the propodium, the top. So this is the scutellum for sure. I believe this next segment here, which is hard to see, let's see if we can zoom in, is the metanotum, and then this is the top part of the propodium, and it's just a line of squarish pits. I'm going to move this a little bit, and maybe I'm going to turn it this direction and turn it on its side some. So we'll zoom in here. So again, scutellum, metanotum, and then propodium with these this line of pits. Zoom in. And there are the pits. We'll change the lighting a little bit so you can see that. They occur regularly. I wouldn't call them common, but they could show up in pretty much any midsummer survey of bees. And if you're looking at hole nesters, these are in the tiniest of holes. Okay, so if we dial
Request
back,
to run cursor along the pits. We're
want me
also at request to run the cursor along the pits, the square
Okay.
pits.
all right, so here, scutellum. This is an interesting shape. I haven't noticed that. That's the, what is that called again? Axilla, but it's not, that's interesting. Never mind. I'm talking to myself now. Metanotum right here. And then these are the square pits on the propodium right through there. Very shiny. Again, let me see if I can take this down a notch with the piece of paper that I can't seem to find anymore. Oh, there it is. So you can see maybe a little bit there as I change the angle on the things. They're reflecting a lot of light at this point. Okay, are we pretty clear on the squarish pits? Okay. So,
Yeah, we got a thumbs up.
okay. All right.
It
So-
seemed to vary in size. Yep.
So I won't get into species level ID except in the male, which I'm going to show you next. That was Heriades. I'll show you I think it's levity. Heriades is usually the most common species, levity and varielosus. The next, and
It is 2:00, so I want to give
Okay.
that note. But we did start a few minutes late and generally flexible on time. Question in the chat before you get started again. Does Cholostoma also have the pits?
Cholostoma is, I believe, does, but I'm not 100% sure. So I'll have to, you can look it up in the guide or look at some IDs, but I'm not sure because I have a different sort of vibe thing on, or what does the cheat sheet say? It may not even mention it. All I want to do here is to illuminate the fact that the males have a big projection there on S2, almost hood-like, that is used in ID. However, the specimens often tend to curl up like this, so they become hard to see. And but a lot of the ID is on this projecting area of S2 right there. And I know we're out of time, so I'm not going to belabor that point, but there's just a slightly different angle S2. Doesn't really, I don't know how broadly that occurs across all Heriades. There's lots of other characters that work well. This also, the male also has those characters we just talked about. So I'll stop there.
Huzzah! If you have any other questions before we wrap up for realsies, drop them in the chat now, or you can unmute. Sam, do you think we're gonna return to Heriades? Any last minute things that you want to do at the beginning of next class?
I don't think so. It's pretty straightforward with that Carina around T1.
Okay, well. Mhm. Just getting thank yous in the chat, so I think we are satisfied.
Okay.
Again, inbox is open. You guys are fantabulous. I'm gonna stop recording now.
Thanks, Claire.
Yay.